In this next video, we're going to look at some reflections, and this is learning target 10.2b. So we're going to take these trigonometric functions, these trigonometric graphs, and do some reflections. So the way that we tell if there's a reflection is if that a value that normally we use for the amplitude, we always said that that amplitude was positive regardless of whether the number, the coefficient, was positive or negative. Well, what that positive or negative tells us is whether there's a reflection or not. So if that first number, or that coefficient of the trig function is negative, so if a is less than 0, that tells us that there is a reflection of the graph over the x-axis, or if it's been shifted up or down, it's going to be over that midline. So the sine curve typically starts at 0 and then goes up to the amplitude. Now with a reflection, it's going to start at 0, 0, but then go down to the minimum and then back up to the maximum, and then back down. So that's with a reflection. With the cosine, the reflection, or with the original, typically it started up at the amplitude or up at that maximum point. Now with a reflection, it's going to start down at the minimum, go to that middle line, go up to the max, back to the middle, and down to the minimum. So it makes a hill as opposed to the valley that it made without the reflection. Let's now look at an example of one of these graphs that's going to have a reflection. So this is an example of learning target 10.2b, and they want us to graph y equals negative cosine of 4x plus 1. So we're going to start out this problem just like we did the last few, where we want to identify the amplitude, the period, the horizontal shift, and the vertical shift. So let's start with the amplitude. So the amplitude is still going to be that number that is in front of the trig function, so the coefficient of the trig function. In this case, there's nothing written there, which means that the amplitude is 1. So then let's look at the period. The period is still going to be 2 pi divided by the b value, or the coefficient of your variable. So in this case, 4, which means then our period is pi over 2. The horizontal shift, so whether it gets moved left or right, that would be if there is anything that is within the trig function that is being added or subtracted to the x. In this case, there is none, because that 1 that's there is actually on the outside since there's no parentheses. So there is no horizontal shift. So then the vertical is the number that is outside of the trig function. So in this case, the plus 1, meaning that we are getting shifted up 1. And then with that negative out front, that does tell us that there is a reflection. So I am going to go ahead and write that down just to keep that in mind when I go to graph it. So now I'm going to go ahead and graph it, keeping in mind when I draw this that I did get shifted up 1. So maybe putting a little more room on the top half of the graph as opposed to the bottom half of the graph. And then I'm just going to make my marks, each of these representing 1. So this is -1 down here and a +1. Now I was shifted up, so I'm going to go ahead and put that horizontal line, that dashed horizontal line across to show that that is now my middle line. And now I need to find those 5 key points. So I'm going to start out the way that I always did. Because there is no horizontal shift, I know that I am going to start at 0, 0. Because this was a cosine, I would have typically started up at my amplitude, which means off that center line I have to go up 1, which would put me up to 2. I would also have to go down 1, which would put me back down to 0. But because this has a reflection, now instead of starting up at the amplitude, or in this case up at 2, that 1 away from the center line, I actually have to start down. So I am going to change my colors here so you can see it a little bit better. And then I start down, so down 1 from the center line, meaning I'm going to be right here at the 0, 0. Then I would go back to my center line. I'd go up to my maximum, back to my center line, and then down to my minimum. So now that I've got my points and I know that I didn't shift it any left or right, I can go ahead and connect those And it does show then a shift up 1 with a reflection over that line. So it makes that hill instead of one of those big valleys that the cosine typically makes. So now let's look at another example that has a reflection. This time let's look at the tangents. And the tangent we haven't talked about yet, but it's very similar to the sine and cosine. The A, the B, the H, and the K all do the same type of things with the tangent. Keep in mind that the A value, even though there is an A value there, it doesn't affect an amplitude just because the tangent doesn't have that max and min like a sine and cosine does, but we can still use that value, that A value, when graphing it. But the H and the K will still do the exact same thing with the tangent function as it did with a sine and cosine. So we're going to start out this problem just like we did the last one, identifying first the amplitude. So the amplitude, remember I just talked about that. The amplitude for tangent is none. There is no amplitude. The period, the difference here with the period is now it is pi divided by the b value. In this case, there is no coefficient of x, so that's just 1. So the period of this function is pi. Horizontal shift, so left or right any. There is something within the trig function being added or subtracted from the x value. It is being subtracted, meaning that this function is going to be shifted to the right. In this case, pi over 2 units. And then our vertical shift is your up or down, or what is being added on the outside of the trig function. So in this case, there's nothing out there. So there is no or none for our vertical shift. Also note that because the A value is negative, there is a reflection. So we are going to flip this. So instead of the tangent function starting down low and then going up, kind of like that, that's what our original tangent looked like. It's now going to go the opposite. It's going to start up and come down. That's what a reflection with the tangent is going to look like. So now I'm going to go ahead and draw my axes. Keeping in mind that I didn't go up or down any, so I still need to kind of keep it centered around the x-axis. Typically, with the tangent, if it was just the tangent of x that we were graphing, we would have a asymptote over here at negative pi over 2 and one at pi over 2. But because this is getting shifted to the right, that first initial one that would have been right here on negative pi over 2, if I add a pi over 2, now goes over to the 0, because if I add negative pi over 2 plus pi over 2, that gives me 0. So I'm just going to put my first asymptote there. Now the second one, if I go to where my second one would have been, so my second original one would have been at pi over 2, and I want to shift that now or add pi over 2 to it, and if I do that, that puts me at pi. So my second asymptote is going to go at pi. So I'm just going to go ahead and make my dashed line there on the pi, at pi vertically. And now I just graph it like I did my tangent function before. So I find halfway between those two asymptotes, which in this case is going to be at pi over 2. So I have a dot there. Now, like I said, our graph is going to look like this graph here, meaning that when I find the halfway between the first asymptote and that center point, instead of going down to my amplitude like I would have with the original, because it is a reflection, I'm now going to go up. So because that A value is 2, I'm going to go up 2, and then that's where my dot is. And then on between the midpoint and the second asymptote, I'm now going to go down because it's a reflection. I'm going to go down 2. And now that I've got those points, I can go ahead and connect them, keeping in mind that it is going to get close to this axis or that asymptote, but not ever touch it. And I make it kind of curve as much as I can. I didn't do the best of jobs there, but there's my tangent function on The last thing I do need to do is I do need to label my axes. So if I find halfway between the 0 and the pi over 2, that's going to give me pi over 4 for that point there. And then halfway between pi over 2 and pi gives me 3 pi over 4 for that second point. And there is then the graph of the tangent. Remember, tangent, we just need one of those. That's the main cycle of tangent that now has been shifted to the right pi over 2.